Alright, so we've come to the final property that we're going to learn. It's called wave speed. Wave speed is basically just the speed of the wave, okay, the speed of the wave, which is the distance traveled by a wave per second. It's the same thing as what you've learned about speed, right? So speed is distance traveled per second. Wave speed is the distance traveled by the wave per second. So the SI unit is meters per second. Alright? So to get a better understanding of what wave speed means, I'm going to use a simulator here. This is like a wave machine, basically just a rope, or I think of this like the marshmallow wave machine. This is an oscillator that's going to move up and down. I can just show you. It's just going to move up and down. It's going to start a wave going, and then the wave will start traveling across, right? So remember what the waves do. Waves transfer energy in a certain direction, right? So we're talking about the wave speed. We're talking about how fast the wave transfers energy across, right? In this case, from left to right. We're talking about how fast this wave motion is traveling across the medium, the rope in this case, right? So when we talk about wave speed, I think it's important to know that I'm not talking about how fast, I'm not talking about the speed of this particle as it oscillates about its rest position, right? This is not what I'm talking about, okay? This is not what I'm talking about when we talk about wave speed. When we talk about wave speed, we're talking about how fast the wave travels across, how fast it transfers energy. Okay, so how do I find the wave speed? Well, just to illustrate this point, I'm going to restart that here. So I have a ruler here and a timer here, right? So I need to find out how fast the wave that manages to travel from here to here, how fast the kinetic energy is transferred from here to here. So this distance for me on this ruler here, it's about 7.8 centimeters. So I'm going to find out how much the time taken is, okay? So without further ado, I'm going to start. And I'm going to start the timer. The timer is here, all right? And stop. Okay, so roughly my speed equals the distance over time. The distance traveled is about 7.8 centimeters. Time taken is about 1.20 seconds. So my speed would 6.5 centimeters per second. Right? That means that this wave is traveling across at 6.5 centimeters per second. If I were to just play this, you would see that means that this wave travels across here in 1 second. Alright, I think it's having it on slow motion now, so it's moving a bit slower than time is moving a bit slower, but you get the point, right? So it travels across 6.5 centimeters in 1 second. Alright, so yeah, that basically is what wave speed is. But can we get a generalized equation for the wave speed using the properties we already know? Okay, so that we can find wave speed without always having to, I don't know, set out a ruler and time the wave, right? Is there a way from the other properties we already know to get what is a wave? Right, so technically, I don't have to use, in this example here, I use the distance from here to the window. But I don't have to use this distance, right? I can use any distance and then record the time taken for the wave to travel that distance. You following me so far? So if I can use any distance, I could also use a wavelength, right? And this is a property that we know. And why would using a wavelength be helpful? So what does using a wavelength mean? That means that instead of using this whole distance, I just want to see the distance for the wave to travel one wavelength. Okay, it's a bit more than wavelength, but you get the idea. So I would just want to use the distance of one wavelength. So let's say this is about 4.4 centimeters. Right, so let's say here I have a wavelength is about, of this wave is about 4.4 centimeters. If my distance, for speed is the distance traveled over time. If I use 4.4 centimeters as the distance that I want to measure, that is basically one wavelength, right? What would the time taken for the wave to travel one wavelength be? What's the time taken for the wave to travel one wavelength? Yeah, do you remember? we've learned this. It's called the period. The period is the time taken for one complete oscillation, right? So the time taken for the wave to travel one wavelength. And so for any wave, if I use the distance of one wavelength, the time taken will be a period. So the speed will be wavelength over the period. I can also get another property involved. I know that F equals to 1 over T. So can you see that this is basically 1 over T times lambda, right? I'm just separating it so that you can see. So V equals to F lambda. And just like that, between these two equations, we have almost all of the properties that we've learned so far, right? And yeah, these are the two really important equations that you need to have in your arsenal. So, and in fact, we can use this as an example, right? So I've set the frequency here to 1.5 hertz. Let's see if this is correct. So it's 4.4 times 1.5 F lambda, right? So my F is, 1.50, and then my lambda was about 4.4. Yeah, I do get about like 6.6 centimeters per second. I know just now I got 6.5, but yeah, this one wavelength is not super accurate because I missed it a bit. So it's a bit less than 4.4. So it's about right? So yeah, it's consistent. Whoa. Yep, so with that, we have our two generalized formulas. V equals to F lambda to find the speed, and F equals to 1 over T, which, right? And of course, when thinking about wave speed, I think it's important to keep in mind that your first principles, right? That speed of anything is just distance traveled over time. And so if the question, if they ask you for wave speed and they actually give you the distance that the wave travels and the time taken, then please remember that you can just simply use speed is distance over time. But other times, if they don't give you any of this information, instead they give you the frequency or the period, then you can make use of these formulas to figure out the wave speed. All right.